Hey everybody, it's Dr. Jensen with the final part of Lab 7, which is the most important part, interpretation. So now you have all this output and you've coded all these variables, and now you got to figure out what all of this means and write it up in a way that provides the statistical information and the substantive information, both what it means numerically and what it means in English if you were describing what you found out to a friend. So let's work through this. So what I like to do is once I have output, I actually like to take a screenshot of it and then just essentially dump it in a Word document. And then I can close SPSS, I can save all my variables and kind of shut all that part down on my screen and then just really focus on the output and what's available here. So again, we're going to just remind ourselves what we just determined. So we were studying delinquency and trying to see if gender has a relationship with delinquency, as well as age that you take your first drink of alcohol. We want to see if those two variables are predictive of a kid being delinquent. So again, we already know there's a relationship with gender and delinquency, but we want to test it and replicate it to see for ourselves if we would find that to be true. And then secondly, the research suggests that early drinking gets kids into trouble, and much more trouble and more serious trouble than their non-drinking counterparts or kids that postpone drinking to a later age. So we want to see if that's actually true. So again, just by way of reminder, we had 15 different items that we put inside our delinquency scale, which covered all different types of behavior: running away from home, shoplifting, graffiti, being rowdy, selling drugs, seriously hurting people, and so forth. Remember, those items were coded as never, 1 or 2 times, 3 or 4 times, etc. We combined all those items and recoded them so that we could just find out if they were doing those items or not. Basically saying, we don't care how many times you did it, we just want to know if you did it. And then essentially, as all 15 of those items were summed into a score, we had a variable that was originally a whole bunch of ordinal variables that we actually built into a large scale that encompassed 15 different kinds of behavior that now is a score. So again, to keep things simple, keep the more or higher scores indicating increases in or literally high scores. So I tell people, you want to kind of keep the direction of the scale in a logical way that makes sense for what you're interpreting. And then again, on the other hand, keep the less or lower scores and the decreases going the other direction. So it's pretty easy to follow. Be sure all your variables are actually going the same direction, or else you will have a scale that washes itself out and you have inner conflicts in the coding. So just keep that in mind. Occasionally you have variables that you might want to include that have to do with the way the question's worded. It might say, do you hit your partner, for example? And if they say yes or I agree, and that's given a low score, and then no, I don't agree is a high score, then you'd actually want to reverse code that, because a high score would indicate they're being violent and contributing to the delinquency score, versus a low score wouldn't. So you'd have to actually flip-flop the values on that kind of an item. So you have to think about, is it positive? Is it negative? Does this response contribute to an increased score, or does this response contribute to a decreased score? So you want to make sure all those variables are going in the right direction. Okay, so in this case, our lowest score was 0, meaning I've done none of the 15 behaviors. I am not delinquent. And the maximum highest score was 15. Remember, we already coded these variables. We ran the analyses, and this was our output that we got. So again, these are the averages across those 3 variables. These are just the descriptive statistics. So again, this is something you would report in a table later. You analyzed 2,518 kids that answered delinquency questions, gender questions, and the age they first drank alcohol. So when you look at these means, they actually tell us quite a bit. The first one is the delinquency scale. So just by itself, what was the average amount of delinquency in this regression model? It's 3.8435. So that means on average between a 3 and a 4 point on the 0 to 15 scale, it means they're kind of moderately delinquent, okay? Now, why is that mean a little different than the original mean of the scale? It's because we're actually using these other variables in conjunction with it, and they're all tugging on that delinquency score in different ways. So the mean in and of itself can tell you something, but once you start adding more variables into the equation, again, it starts contributing to something called a regression line that's going to try to plot out the relationship between A and B. Now gender, the mean for gender doesn't tell us very much because essentially we coded gender as 0 versus 1. So this is the average of all the zeros and the average of all the ones. So we would expect it to be a 0.5 because we have almost half as many males as we do females in the data set. So it's not terribly meaningful to know that 0.5 is the average for gender. Gender is not really something we average. You don't average a category. So we don't really need to pay much attention to that. But look at the age the kid first drank alcohol. 13.38. That means the average age a kid started drinking was age 13. Okay, now again, look at the question wording. You can see, is this more than a glass of wine at dinner with your parents? Is this you drinking without parent supervision? What is this? So you want to make sure you get after the descriptions of this variable. This is a really fun variable to work with if you're interested in using it for your research paper. So you can go look this up in the code book so you can get more detail as to what it's about. All right, going into the output. The model summary, these are statistics that pertain to the entire model, right? The R-squared value, which tells us essentially how much variation we're explaining in delinquency given knowing their gender, given knowing the age they first drank alcohol, etc. This is a pretty low R-squared, so we're not jumping for joy that we solved the mysteries of the universe, but we will report this later in a different section. Again, we don't really report the ANOVA per se, but we do go all the way down to those coefficients. So we have a constant, we have a coefficient or a B for gender. We also have a coefficient or B for the age they first drank alcohol. And we also have these significance levels over here. So let's talk about the 4 pieces of information that you're going to report when you write up an interpretation. The first thing you report is, number 1, were there significant relationships? The second thing, number 2, is you want to talk about that constant. The constant usually tells us something most of the time. There are occasional times that it doesn't. Occasionally you can get negative constants, which we don't usually interpret, but they are mathematically possible. In this case, this one is significant. We'll talk about what it means. The third thing we report is the B coefficients that tell us kind of how those scores are working to predict that regression line that's going to tell us how much delinquency is going on with each kid. And the fourth thing is the R-squared value, or how does this whole model do at trying to explain delinquency? Are we getting a pretty decent line that shows a relationship, or there's still a lot of things to be said? Well, this is how we write it up. So these are our numbers. This is our output. This is how we write it up in English. And you can kind of mimic this in your interpretation. So first of all, I determined that there is a strong negative relationship between a juvenile's gender and the delinquency they commit. Okay? The constant or approximate mean score of delinquency a kid commits on average is 7.733. Okay, so that tells us on average, by knowing these other things about them, we can predict that they would probably be doing about 7 out of the 15 delinquent acts. Okay, again, that's because these variables are having effects on each other and they're all kind of tugging at this line that we're actually trying to graph. Because remember, these B coefficients are slopes, okay? And the constant's the y-intercept, right? So you're literally graphing a hypothetical line that's going to show a relationship between X and Y, okay? Females have a statistically significant relationship with delinquency completed as compared to males. So we know that because right here with gender, we have a negative 1.066, and on the very end of that line where it says significance level, we have triple zeros. That is a highly significant result. So we know it's highly statistically significant. And again, we have to remember how we coded this variable. Females were 1, males were 0. So you always start with the ones on a nominal variable when it's just this category versus this category. So we say females have a negative coefficient of negative 1.066 acts, or scoring lower than males. This means that girls are committing 1 delinquent act less than compared to boys. So that girls are actually committing 1 fewer delinquent act than boys are. So basically, girls are less delinquent than boys. That's what you just found out, and those are the statistics that can prove it, okay? This is worded a little funny. I'll say less, one delinquent act fewer, or 1 delinquent act less than boys. That's probably the easier. But again, what you want to remember is you're making comparisons in categorical variables. So you always talk about who is the one and what effect they have, whether it's positive or negative, compared to who the 0 is, the boys in our case. okay? Then down here, we're going to get into the age variable. So that was negative 0.249 on the coefficient. And again, highly statistically significant over here. So we can start writing about this one too. Another significant relationship is present with the age a juvenile has their first drink of alcohol. For every 1 year in age, and this is an interval variable because remember it was years, how old are you when you have your first drink? And so it was a quantity and age in years. So whenever we interpret interval variables, we interpret it a little bit differently. It's always a 1 unit increase in X is this subsequent change in Y. So for every 1 year age in a kid, for every 1 year in age that a child develops and grows, they commit 0.249 fewer delinquent acts. Okay, and really to be specific, for every 1 year in age that a child refuses to drink, right? For the first time, they commit less delinquency. So that's a huge finding. So for every year they postpone having their first drink, they actually tend to get into less trouble. Okay. So again, we kind of reference what that B coefficient is. For every 1 year in age that a child refuses to drink alcohol for the first time, they commit 0.249 fewer delinquent acts. Okay. And again, you just can kind of describe what it means in English. This means that as children postpone the age they have their first drink, they tend to participate in less delinquency. So that's what it means in English. You could say that to somebody in a sentence without them even seeing a single statistic. And they'd go, oh, what did your research find out? Well, actually, we found out when kids don't start drinking at early ages, they stay out of trouble a little bit better. I mean, you could say that and they know exactly what you mean. And again, just a finishing statement, this relationship is also highly statistically significant at the p is less than 0.001 level. So again, just to reassure the reader, not only do we find these changes in coefficients, but we're very confident that this is actually true beyond chance. Okay? And then finally we wrap up, because this is the entire model we're talking about, with the R-squared value. The R-squared value of 0.080, again, the way we interpret R-squared is we can take that number, multiply by 100, and essentially you get a percent of variance explained. So if we multiply 0.080 by 100, it turns out to be 8%. So only about 8% of variance in explaining delinquency committed can be accounted for by the model variables, like their gender and their age at their first drink. So this tells us that there are likely other factors which contribute more to the explanation of how much delinquency a kid commits. So we can't just solve the mysteries of the universe and predict exactly how delinquent kids are going to be only by knowing their age at their first drink and only by knowing their gender. There are certainly other things that predict how delinquent a kid is going to be, but these tell us we're on the right track. We're just not getting a lot of mileage out of them. So think of R-squared as how important variables are in understanding a truth about the world. So, you know, on the surface, you can say, oh, these are highly statistically significant variables, right? You know, age at first drink and gender, they're highly significant, but how important are they in really trying to explain delinquency? They're not earth-shattering. They're only covering about 8% of what would explain a kid's delinquency score. That means 92% of their score could be explained by other things, and those other things are probably even more important. So again, R-squared is kind of how well does the model do at explaining your outcome. The B coefficients just tell us specifically what are those changes that each of those variables are having on your outcome. Like this one is negative and it's bringing the score down. Maybe another one's positive and it's pushing the score up. So when you get into OLS regression, it's all about increases and decreases. Okay, so you can use language like it's negative, it's positive, it increases, it decreases. And that's kind of how we interpret OLS regression, because it actually works with interval style variables. So if you have a scale that turns a variable into a quantity or an amount of something quantifiable, something numerical, you're probably going to be running OLS regression as your regression of choice. Okay. If you end up having an outcome that's more of a category, then we have another regression for you that you're going to run. That's binary logistic regression. And there are certainly lots of others that cover different kinds of nuances in your data. But again, hopefully this helps you kind of walk through the outcome, the output, putting it into words, focusing on what pieces need to be written about, But this is kind of just a modest paragraph to show, okay, these are significant variables. This is literally what those b coefficients mean. This is what it means in English. This is what the constant says. And this is what r squared tells us. And that's it. So again, the more variables you have, the more paragraphs of interpretation you'll have. But since we only were working with 3 variables, we didn't have a whole lot to write about. So hopefully this gave you a little taste of OLS regression. And if you have questions, please let me know. We'll see you later.